Thank you so much. Good morning, everyone. Good afternoon. My name is Calvince Wara. I work with the Nile Basin Initiative based in Entebbe, which is an initiative comprising of 10 member states country who depends on the River Nile. I work there as the Regional Hydromet Coordinator, supporting operations and maintenance of the Regional Hydrometric Monitoring System, but also development of information product. I would like to share with you our experience in the Nile Basin in terms of the establishment of the regional hydrological monitoring system and how we leverage the system operation and maintenance, but also the development of information product that supports the basin operations in terms of water resources planning, but also advisory and guidance when it comes to hydrological extremes like flood and drought. So, as I indicated, the Nile Basin is an initiative of 10 member states countries that depends on the River Nile. And the member states countries, in their own wisdom, have tried to come up severally to come together severally to address the common challenges within the Nile Basin, especially related to water resources planning, development, but also realizing that the water resources planning and development requires monitoring and data. In this regard, the member states had their first international technical corporations. As a platform for regional corporations, they have their first conference. And this was based on hydrometeorological monitoring survey project that started in the Upper Nile. And the project was called Hydromet. That is in 1967 all the way to 1992. Then followed again with the Technical Cooperation Committee of the Protections of the Nile, the project we call Taco Nile, that brought all the 10 countries together to ensure that the resource that they're depending upon is monitored but also protected at the same time. Because of these two initiatives, the Nile Basin Initiative was developed or was born on the 22nd of February 1999 as an inclusive platform that ushered in a new era of cooperations within the Nile that started with the jointly monitoring the river basin. In recognition of the needs to get timely data, but also accurate and reliable data, the countries developed a Nile Basin monitoring strategy of 2010. The aim of this strategy was to establish a suite of the regional monitoring programs that aims to support water resources planning, but also management within the basin. The strategy decided that to optimally monitor the basin, 322, this is a basin of about 3 million square kilometers, and they established that optimally there are 322 meteorological stations that are needed, 79 hydrological stations at hydrological location, inclusive of 52 stations being water quality and 43 being sediment monitoring station. The focus of the hydrometeorological monitoring system of the Nile Basin is to support transboundary water resources planning, but also stability of the member states in terms of exploitations of the water Nile for various economic activity. In this regard, design and implementation of the Nile Basin monitoring system was developed and approved in Tanzania, Dodoma, Tanzania in 2015. And through the funding of the European Union and the German Development Agency through JZ, NBI or Nile Basin collaborated with the member states to establish Nile Basin Regional Hydrological Monitoring System as an upgrade of the national station and the national data management system on a strategy. This envisioned 60 hydrological stations in phase 1 being procured and upgraded across 9 member states, as you can see from the map on my left-hand side. The regional system provides real-time data, and this data include the river water levels and river discharge, the lake levels, the rainfall, accumulation and intensity, and the water quality parameters all loaded into the same system, providing temperature, pH, electric conductivity, turbidity, dissolved oxygen, ammonia, nitrate. This is to look at the component of the pollution. The configuration of the hydromet system is based on telemetrically transmission to the regional data center, but also to 9 national data center, but also to 2 regional data center. The transmission is dual, leveraging on the GSM communication in various member states, but also the satellite as a backup for the through the UMETSAT. If you look at the photo on my left, there are stations. One is a walk-in shelter with the rainfall, rain gauge and other meteorological variables on top, but also inside the walk-in shelter, there's a logger that keep on monitoring the water, the river water level variables, and compare this to the rainfall. Various capacity building across different countries has been done in terms of the operations and maintenance of the monitoring system, but also leveraging on the information that is emanating from the system. In terms of data access and setup, uniquely, member states are provided with their own login credentials, and we have adopted a regional data management system for the purpose of the standardization, but also the interoperability of these stations from one data management system to the next, but also to facilitate the access to the ease with which data can be shared across the borders, but also within the basin. The data management system allows quality control, analysis, and also reporting. And in terms of access, has been made easier is through a heavy access through parallel client, but also from the web portal like the DS Web, but also a mobile app has been provided in terms of data access. Across the different regions, looking at the rainfall, but also the water quality, the river level water data that is being collected across the region in different countries from the system. We have handed over this system to the national government to support in terms of planning, but also the operations and maintenance. The photo you see is handing over of the 6 regional stations to the government of Rwanda through Rwanda Water Resources Board. We also undertaken the handover in South Sudan to the Ministry of Water, Resources and Irrigations. We have also handed over in Uganda to the Ministry of Water and Environment to support operations and maintenance of these stations. We have also done the same in Kenya and also in Tanzania, Burundi, and other countries as well. In terms of the operations and maintenance, this is where we had the greatest challenge because of the requirement also, but also the capacity, given that it's a high technology, there need to be a transition period where NB-High supports the country to operate and maintain, but also at the same time building the capacity. Looking at the operations for all the 60 stations across our countries, you'd see that the station is 88% operational. It means that there are some components or some malfunctions of the station in some parts of the countries, as you can see across. In terms of the challenges, of course, there's limited funding. To operate and maintain these stations require a huge amount of funding, and this funding is often not available or not adequate from the member state point of view, but also the regional context. We have had experience with the vandalism at the station level where the community, where the stations are installed, simply do not understand this, do not appreciate the significance of the station. We have malfunction component, data transmission failure, but also sometimes you get unrealistic measurement, and some stations also being washed away by floods, or some have been burned. One have been burned with bushfire, especially in South Sudan, sorry. Also, you'd understand that the abbreviations of the water level is a very limited aspect, especially when you want to make decisions regarding the water quantity, the water flow, timing, as well as being able to generate some meaningful information regarding to early warning. Now, in this case, we have done significant effort to improve the accuracy of the in-situ monitoring station in terms of reliability, but also the data that is being obtained is accurately and reliable. To do that, to curb the issues of vandalism, but also malfunctions of the station, as well as enhance applicability, we have enhanced the capability of the monitoring system to leverage or benefit from some of the derived satellite available information regarding the river flows, but also river flow conditions. In this space, we have leveraged on the 2 global products. That is the GeoGloss Steam Flow Service that is hosted by the ECMWF, but also the GLOFAS, which is equally hosted by the ECMWF. And we have leveraged on this based on the simulations of the 80 years, but also the retrospective, looking at the river for the last 80 years. What does that tell us? Because sometimes you experience data scarcity, but also you are not able to instrument everywhere in the river location where this information is needed. So to help us do this, we are leveraging on these two global products, and we blend it, bias correct them with the in-situ data to ensure that our data or the information we get is localized to the local level. So the monitoring system data, we use it to bias correct the global satellite data, and then the data becomes available, and also the capability to be able to forecast the river flow conditions beyond 15 days to 1 month and as well as 2 months in terms of preparedness. Those are the time of the bias corrections between the satellite and the in-situ data. The in-situ data is in blue, and the green one is the satellite derived that is bias corrected. And you can appreciate the value of the satellite derived product as well in this particular space in terms of the way it reproduces the hydrograph in terms of accuracy. In terms of the magnitude when it comes to eye flows, I think the limitation is more the in situ station as opposed to the satellite derived, but you'd appreciate the accuracy with which this. Once you've bias corrected and localized this, then we are able to see focus for the next 30, 45 days to 50 days on how the river is going to behave, responding to the climate variables such as the rainfall and losses to evapotranspirations. And this is done through the lake level, but also to the discharge that we can get. Looking at the system or the kind of decisions that we leverage in the system, we do focus. So, for example, we know from various parts of the river system how they are going to behave from the period of June, July, August, September to October. And this is very important in terms of informing the planning, but also in terms of identification of some flash flood, but also riverine flood specifically for disaster risk reduction. But also it's very important to the water supply, irrigation, water demand, as well as the hydropower operations, so that they can plan their scheduling, irrigation scheduling, but also optimize on operations accordingly. In doing so, Nile Basin through the system developed Nile Basin seasonal hydrological outlook. This is an outlook that is developed to forecast the river flow condition for the next season and to advise the countries in terms of the strategic planning, but also in terms of specific interventions that can be instigated way ahead of time. For example, if we identify that the river is going to flow beyond normal capacity, it means that there are certain measures that has to be put in place to ensure that the risk of flooding or disaster due to flood is reduced. We use the data from the station for strategic water resource assessment and quantification for the purpose of planning, but also the forecasting for the drought risk reduction, but also for the hydropower operations. In this, we have established a regional expert working group in hydrology that meet frequently to look at the data that is coming from the system, but also collaborate with other partners that generate meteorological forecast to ensure that we have a clear understanding on how the forecast meteorology is going to impact the hydrological behavior of the system, but also the implications of the different sectors of the economy, looking at the agriculture, irrigated agriculture, but also the energy sector within the power generation, water resource availability in that space. A classical example also in hydropower operations. So we move from the monitoring of the climate variables to monitoring of the streams, but also to be able to forecast how much hydropower would be generated for company. This is a case used for Rusumo hydropower, that an hydropower that is supporting 3 member states countries is located in the boundary between Rwanda and Tanzania, but it provides hydropower of 80 megawatts equally distributed to Burundi, Rwanda, and Tanzania. Therefore, this hydropower holds a regional significance to this country. We have worked with the heads of national hydrological services to ensure that the support and operations of this system is provided. And in return, I heard our colleague from Benin or Ghana talking about how they met Ghana as work with the private sector. This is also a classical example to working with the private sector to ensure that the operations of the hydropower is optimized, but also is planned. In return, the hydropower would support operations and maintenance of the monitoring stations that provide them with this information. So the lesson learned from the Nile Basin in terms of establishing but also operating an hydromet monitoring system for the purpose of water resources planning and management include political commitment. This requires political commitment, given that different countries, different regions have specific interests into parts of the river basin. There needs to get that political commitment. In doing so, Nile Basin, through the governance structure, as the Nile Technical Advisory Committee, which are simply supported by the Nile Council of Ministers, who are the member states representing the water affairs in their own respective countries. So to establish such a system, the political goodwill was needed in that zone. Then the system is designed robustly, taking advantage of the latest technology of data collection, but transmission to both the national center, but also the regional center. In doing so, we implemented a dual transmission system, leveraging on the GSM telecommunication, but also the satellite technology via UMETcast, UMETSat that is provided by the ECMWF in that space. This ensure that at least the data is available in time, but also in real time, but also it is reliable in terms of that space. In terms of the comprehensive capacity building, given that it's a new end technology, we have built the capacity of the member states across the basin to ensure that the system is is installable, but also operations and maintained as part of the sustainability plan. We have also established the regional expert working group in hydrology consisting of heads of the national hydrological services in our member states country to spearhead operations and maintenance of the monitoring system, but also to ensure that the data that is coming from the system is accurate, reliable, and the information product that is being developed from leveraging on that system is goes into the planning and operations of that. So that team is an active team. They meet twice in a year, but also quarterly when it comes to generation of the bulletin in that space. It consists of 3 experts from each of the 3 countries. So you'd understand the number of around 30 experts sitting in a room looking at the issues of the Nile. I talked about the vandalism of the stations. This mostly come from the community. And we have learned that strong and local engagement with the local community is very key to reduce this. We have tried to carry out sensitization and engagement for the community to understand the value of the monitoring system, but also how the information from the monitoring system affect them or can help them in that space. There is a Nile Basin Discourse, which is a local community-based organization that look at the issues of the community benefiting from the Nile as a resource. So we have leveraged them to enhance citizen science in which the community can be, ways in which the community can be engaged to understand the system, but also to be part of the data collection for validation of what is coming from the system. Need to diversify financing and sustainability because countries always have inadequate resources for the purpose of the operations and maintenance of the monitoring system. So in that regard, there's need for partnership and collaborations with the other agencies. And I've provided a classical example where NBHI is partnering with the hydropower company called Rusumo, which is a limited liability company in the private sector, to operate and maintain this monitoring system. And that has proven to be very vital, especially for the 3 countries that share the resources from the hydropower as well. The data management infrastructure, but also the sharing of this information. The data security for country to, allow within this, Nile Basin is a platform to ensure the cooperation, but also to ensure peace and stability. The issues of water resources is a conflict-prone area that if it is not carefully managed, then the country can end up, it can end up being a source of conflict in itself. especially with regards to sharing information. We know the hydrological system is transboundary in nature, therefore it does not respect the laws of one country to another as it transcended. And therefore, in this space, sometimes the data sharing become a common issue because the water is itself is a resource and a very vital product for contribution into the country's domestic product. And in this regard, some countries would be feeling a little bit shy to share their water level data or their water resource data with other countries because of the common reasons that we know. In this space, we have ensured that the data management infrastructure is only accessible to the countries allow credentials, login credentials, and also when it comes to development of public information product for consumption, the experts working group decides on the discretion of the countries in terms of which information is critical to put in the public domain and which information is too critical not to go into the public domain. So in that space, there are a little bit maneuverability in terms when it comes to the political goodwill on sharing data, because some countries are upstream and some other countries are downstream. So what happens upstream definitely affect what happens downstream, as you know. This need to demonstrate the value of the investment of a hydrological monitoring system. The demonstration of the value of this investment in the monitoring system is normally done through the kind of information, but also in the kind of that information supporting which decision for the countries. In that regard, we are trying to promote and showcase the value that we receive in the monitoring system, the value of the investment that in the monitoring system through sharing, developing hydrological information product, sharing this information product for various decisions, especially on the flood risk reduction or the disaster, flood-related disaster risk reduction. There are also challenges with the security issues. We have had conflict in different parts of the basin or involved member states of the basin, and this conflict normally impact in terms of the operations, but also maintenance, but also the data sharing or the working harmony between one country to the next. And therefore, one key lesson learned is that it's good to ensure that the resource or the monitoring data become a contribution of peace and not a disagreement in itself in that space. That's the bit I can share with you in this space. Thank you so much, and I would welcome any comment from your side.